So without further ado, I'm going to introduce you to Dr. Eoin Murray, who is Aquamonitrix Head of R&D, and he's going to give us a presentation on solving one of the technology gaps in RAS. So I'm going to disappear and hand you over to Eoin for the next 10-15 minutes. Okay, thank you for attending, and we'll speak again soon.
Thanks, Mike. Okay, let's run through some slides then, and as Mike said, we can take some questions at the end. So this talk highlights a portable and deployable analyzer for in situ continuous nitrate and nitrite monitoring within aquaculture and more specifically recirculating aquaculture systems. So in the presentation, we'll touch on current technology challenges. We'll highlight how Aquamonitrix works and how is it different, and we'll also touch on the value Aquamonitrix can bring within RAS and when considering RAS management. So in terms of current technology, of course, there's a whole range of different options and there's many strategies out there when considering in situ or online monitoring, such as ion selective electrodes and colorimetric based systems and so on. But really, UV probes are often considered a leading technology when considering online nitrate monitoring. But in the RAS setting, a number of issues need to be considered, and we'll touch on some of these now. Firstly, UV probes are not selective for nitrite and nitrate. They can't discriminate directly between nitrite and nitrate. There's also other issues to consider around interferences, such as interfering ions, but also dissolved organic matter, turbidity, things like that. They also need to be considered when measuring using UV probes. In addition, of course, biofouling is another big consideration which comes into play. Another key issue when considering RAS is, of course, the salinity. So salinity can have a big impact on UV probe performance, and especially when considering analysis of nitrate and nitrite using UV probes. So we'll go into a bit more detail on that in a moment. And then the final issue, which I hope we would all agree, the issues around typical grab sampling, the grab and lab approach. When considering process control, it's simply really not good enough because it only delivers poor temporal and spatial information. And when considering process control, you really need in situ continuous monitoring. Often grab samples as well, they're based on colorimetric methods, and these methods can be impacted by varying salinities as well. So it's another issue to consider. So looking in more detail around the issues associated with direct UV measurement and using UV probes for nitrate and nitrite, the key issue is around selectivity. So if we look at some absorption spectra for nitrite and nitrate, we'll see that both NO2 and NO3 absorb within the same UV region. So using a direct UV probe, you can't discriminate directly between nitrite and nitrate. Algorithms need to be applied to get the estimation for NO2 and NO3. That's the first point. But when we're looking at salinity, the situation gets a lot more complicated. If we look at the absorption spectra to the right, as you can see, high levels of salinity, it absorbs within the same region as nitrite and nitrate. So varying salinity and high levels of salinity has a big impact on the measurement of nitrate and nitrite, and UV probes directly can't selectively measure for NO2 and NO3. Algorithms and estimations need to be carried out to overcome those issues. So in terms of our system and how is Aquamonitrix different, how does it add value, how does it overcome these challenges essentially? Well, the analyzer combines rapid ion chromatography with UV LED based detection. We also use a sodium chloride eluent, which we'll touch on in a moment to give a bit more detail. But by using this eluent, this gives us salinity independent measurement. Again, we'll go into more detail in a moment. But ultimately, through the separation of ions in combination with UV LED based detection, we achieve true selectivity for direct measurement of nitrite and nitrate across freshwater all the way up to fully saline. So in terms of the analyzer itself, this is just a fluidic schematic of the analyzer, which we won't go into we won't go into great detail on it. But the key point is, as you can see, essentially it's a portable, rapid ion chromatography based system, and everything is enabled through the use of a anion exchange separation column. The analysis then, or the detection, takes place using our patented UV LED based detection system. And we use a deep UV LED, which allows for the direct absorbance measurement for nitrite and nitrate. And what the system looks like, so this is an image of the actual system itself. But the key point is, as you can see here from the chromatogram, this is all generated internally or behind the scenes within the system. The system automatically does the peak integration, generates the concentration from this chromatogram. But as you can see, resolved selective detection of nitrite and nitrate essentially is what is delivered by the system. In terms of the analytical range, for nitrate, it's 0.6 all the way up to 500 milligrams per liter as NO3. For nitrite, it's 0.05 all the way up to 100 milligrams per liter NO2. So a very broad range, applicable to a whole range of different applications, but very nicely applicable to the RAS setting. So moving on to that then, let's have a look at how it really overcomes the salinity challenges and how it adds value within a RAS application. So this is a real unique advantage which our system delivers. So as I mentioned, we use sodium chloride eluent, but the process is called on-column matrix elimination. By using a sodium chloride eluent, the chloride matrix ion in the eluent essentially overcomes the matrix effect of the saline samples. So using one calibration, we calibrate in factory, the analyzer can accurately detect nitrite and nitrate in varying salinities. So the system can be deployed in a freshwater setting to begin with. Salinity can change during the course of the process, all the way up to fully saline, and the accuracy for both NO2 and NO3 is maintained. And just showing the data here, this is basically precision and accuracy data across varying salinities. As you can see here, the accuracy and precision is maintained despite the fluctuating salinity. And really then, if we look at a kind of a more in-depth look behind the scenes on the system, as you can see here, the freshwater chromatogram is shown at the bottom, 20 ppt salinity is shown above, 35 ppt salinity is at the top. So despite the varying salinity all the way up to fully saline, the chromatogram remains consistent, the peak area is unaffected, and our accuracy is maintained. So it's a really unique advantage which is delivered by the analyzer. To touch on, there's a whole range of different case studies, but we just wanted to highlight an interesting one here. A key advantage which the system where the system can add value is the area of biofilter startup. So this was a deployment in Norway, and in theory, there's two RAS systems here, but in theory they were identical RAS systems. But as you can see, in one RAS system, the biofilter was operating as normal, but on the other, the NO2 was essentially going out of control. The NO2 levels were increasing dramatically. Because the operator had this real-time data, they were able to take action. So they took biomedia from the RAS system that was operating as it should be, dosed it into the RAS system that was essentially out of control, and they pulled it back into allowable or acceptable limits, and that's what you can see here. The NO2 levels come back to normal or where they should be. Another key point here is this is all remotely accessible. So we have a proprietary IoT platform which is available, but also we have customers that are using our system within their SCADA systems for process control as well. So that's available. To touch briefly then on other applications where the unit adds value. Of course, final effluent for emission of nutrients. Some customers are using it within that application. Improved low water usage is another area which is some customers in Canada are using and Australia are using. And then also understanding of feeding and maximum feeding and so on. That's another potential area where the real-time nitrite and nitrate data is useful. So that was just a quick overview of the unit and some of the technical aspects of the unit, but we'd welcome any questions. And of course, please feel free to get in contact if you'd like to have a Teams call or go into more detail. We'd be more than happy to go into more detail with you. Thanks.
Okay, well, thank you very much for that, Eoin. We have had some questions coming through in the Q&A, so I'll post them to you in a second or two. Just to let everybody know as well, our background host does have the ability to bring people in. If you've got a live question you'd like to ask now, we can unmute you. Just raise your hand, and Colin will bring you in. But the first question that we have in the chat here, Eoin, is how often do you need to the question is recalibrate the column or exchange the column matrix? So this is a question around the longevity of the IC column.
Yeah, no, it's a great question. So initially, surprisingly, the columns are amazingly robust. So initially, we were of the impression that the column was going to be a consumable part, and we would have to change it quite regularly. But in what we've established over the past number of years is they're amazingly robust. So I mean, at the moment, depending on the application, but typically within a RAS setting, we achieve about 5,000 runs, 4,000 to 5,000 runs on a single column. We can identify when the column, if and when the column needs to be changed based on the chromatograms. So obviously, as retention time changes, we can proactively recommend when the column needs to be regenerated. That's the first point. But it's the second point is we can actually regenerate the column. And once we carry out that regeneration step, it's just a case of replacing or installing that same column back into the unit, and it doesn't need to be recalibrated. So again, we've done all the experimentation around that, and the column is essentially 99% what it was as new after that regeneration step. So that's typically what we do on the regeneration of the columns.
Okay, and just one thing I would add to that as well. The other thing I think we found, Eoin, was that when we do change the columns, it doesn't have a detrimental effect on the accuracy of the instrument. We at first thought changing a column would necessitate a calibration, but I don't think we've even found that, have we?
Yeah, exactly. That's what I was just saying there, Mike. There's no need to recalibrate. It doesn't need to be recalibrated after regeneration of a column, or in fact, if we replace it with a new column, it still doesn't need to be recalibrated, which is a big advantage. We've tried to make the system as easy as possible to maintain and to install. So obviously, calibration is a big challenge for some other competitor systems, which we've tried to allow for and factor that in.
Okay, we've got a couple more questions coming in here, so we're going to keep you busy here, Eoin. There's a question coming in from, forgive my pronunciation, but Beynud Fathi, which is around: is the analyzer true real time, or is it a sampling system which makes it look like real time because we're taking lots of numbers?
Yeah, I mean, technically it's near real time, isn't it? I mean, if you look at the fluidic configuration of the system, we actually pull a sample into the system and analyze an aliquot of the sample. But it's the 10 minutes is basically the quickest sampling frequency that we can deliver based on the analyzer. What I would say is, I'd say across, say all applications really, the typical kind of sampling frequency where most customers end up is every hour. At the start, sometimes we can be very eager to deliver every 10 minutes, every 15 minutes. But what we found is in general, macro trends are typically captured within 1 hour. We have some unique applications, especially around wastewater and aeration tanks and things where the sampling frequency, they need 15 minutes, but typically for most applications, 1 hour is appropriate in terms of sampling frequency.
Okay, I'm glad you're on this call, Eoin, because I definitely wouldn't be able to answer this one. So we have a question coming in from Nicoletta Rory. Again, forgive my pronunciation. Hopefully I made a good stab. It's referring in detail a little bit here to the chromatography itself. Maybe, Eoin, if you can see the question, you could read that one. It'll take some time to if you could read that one, and then I'll handle the next couple of questions. If you read the one from Nicoletta and have a look, it's a long question.
Yeah.
I can answer the question here from Thomas Mosquera. Thank you very much for your comments about the presentation. I agree, it was concise and to the point. And it's just a question there, Thomas, about is it sensitive to the salinity? And as Eoin said in the presentation, it isn't. You know, the accuracy and precision of the measurement is maintained between freshwater and fully saline. It actually doesn't impact the reading. So if there was a situation in an aquaculture where you were increasing the salinity, maybe during, you know, as we're going from small fish up to smolts, you might see an increase in salinity as you're going through that process. You wouldn't have to recalibrate the monitor. So hopefully that answers that. We have a question as well about 5,000 runs and how many days would that be? Well, as Eoin has said there, we've found that most of our aquaculture customers have gravitated towards an hourly reading. So it's really a question of dividing 5,000 by 24, which once upon a time when I was younger, I would probably have been able to do in my head. But I'm going to say 5,000 divided by 24 is probably 200 days. So it's quite a long time, really. Something like that in terms of changing the column. So it's well over 6 months. We then have a question just about a different application from Sheena, asking about wastewater treatment plants. Can we measure nitrite and nitrate in aeration basins? Absolutely, definitely. And we will be running a webinar on our applications in activated sludge, Sheena. But the answer to your question is yes, we have got excellent data from even in the aeration basins, and we're working on greenhouse gas reduction and energy optimization in that area.
So Mike, I'll respond to Nicoletta's questions there, if that's okay.
Yeah, absolutely. We've got one more question. And there we go. Yes, if you handle that one, because that's over my head, I'm afraid.
That's okay. No, so there's some great points there. Obviously, you have some experience on the chromatography side, but interestingly enough, our column is actually it's a guard column. So we're not that interested in, you know, efficiency. All we want is to do a simple separation between the NO2 and NO3. So because we're using a guard column, it's low back pressure, and it allows us to basically, create the system the way we have. So in terms of replacing columns and so on, I think we mentioned the column life, but yeah, we're the column that we have other columns available, but typically we're aiming for a guard column because of back pressures. Low back pressures is what we're after, and because we have a highly selective patented UV LED based detector, we're not that concerned about interfering species because it's so selective for nitrite and nitrate. Your question around the sample inlet, again, it's to do with our fluidic based system. We overcome a lot of the issues associated with biofouling and things like that. That would be more typical for UV probes and other competitor systems. I mean, it would be great if you'd like to get in contact with us. We can give you a lot more information on the system itself, and it would be very nice to understand some of your applications and where potentially the analyzer could add value for you. So if you'd like to maybe continue the conversation after, we'd appreciate that. And I think it could be useful for both parties, really.
I'm famously on mute. My apologies. So we've got questions coming in thick and fast. We've still got 10 questions open. The the maintenance costs and running costs is a theme which a couple of people have asked about. That is dependent upon your measuring frequency in terms of the cost of consumables. So the one consumable is eluent, which is a dilute saltwater solution, very relatively low cost. The other consumable would be the column in terms of things that are used up. So an OPEX in an operational cost in a typical application is under €1,000 a year. And that's a typical, cost. And if you were running at incredibly high frequencies, maybe that would go up, but not significantly. That's a ballpark figure. So that's the answer for somebody on one of the posters. Tiago Sa has asked about accessing the software. So as Eoin touched on there, this instrument is fully IoT enabled. It's supplied with a modem. It connects directly to proprietary software, which you can look at on any web interface. At the moment, we haven't fully costed a subscription-based model. It comes with the analyzer, but we're working on that. So we can take that discussion further if you'd like to do that one.
Like I see there's a question around ISO and
Yes.
performance. I think that's an important point. We recently obtained an ISO accreditation for the analyzer for performance. It's the ISO 14034 around online analyzers and so on, and it was in a wastewater application, but a very long process as all accreditation processes are. But at the moment, to the best of our knowledge, we're the only commercially available analyzer that has an ISO accreditation for performance on nitrate, on nitrate monitoring. So yeah, in terms of accuracy and performance, we really stand over our typically for most applications, we expect 95% accuracy and precision plus or minus 5%. So, and that's across salinity, that's across freshwater and fully saline. So in terms of analytical performance, we really expect lab quality analytical performance from the online analyzer. Just to make a point of that.
Okay, thank you, Eoin. And then Benood's followed up a question. He says, thank you for the previous answer. He's just asking on one of the graphs showing the different salinity, there's a spike of nitrite, which he's saying has occurred all of a sudden. May I know how big the jump was? I think it's just a question of what were the units on the left hand side. So I think it's just asking about what it may be. Let's have a look what we've got. We still have 5 minutes. I don't know if you can go back to the graph and we can just explain a little bit more detail about so I don't remember seeing a spike. It may be the injection peak. I don't know.
Yes.
Is that so I think it may be this spike here that's the first spike there is the injection peak. If you can maybe elaborate on what the flips are.
Yeah, so the injection peak is essentially it's different for the saline matrix, of course, because there's a whole range of different or added anions and cations in the sample versus the freshwater. So that appears as a different injection peak, but doesn't have any. We're not interested really in the injection peak. All we're concerned about is the peak area of the nitrite and nitrate, and we do see slight band broadening for NO2 and NO3, but the key point is doesn't have a significant impact on our accuracy and performance. And really that's what it's all about for us. We're not looking for the perfect chromatogram. Ultimately, we're looking to deliver robust, accurate analysis in situ. Really, it's all about the accuracy on the nitrite and nitrate concentrations.
Okay. Thank you for that, Eoin. He said in the next slide. So the next slide after that, this one. So there's a spike. There's a blip there. Okay. So let's have a look. So what's the question? Oh, he's just asking really for the units. So the units are parts per million or milligrams per liter as nitrite. So the biggest peak I can see there is a 6 ppm. But the purpose of this graph is really to show that even though these two systems were in theory identical, one of them started to exhibit a nitrite issue. So the nitrite on about April the 8th or 9th, you can see it starting to rise to levels which would have caused concern. So it, instead of dropping off as the filter matured and came into operation, something happened with the biomedia, and the nitrite just went rising and rising and rising until they made their intervention. Then it dropped back down. And you can then see that once they've done the intervention, if you look at the right-hand side of the top graph, the nitrite peaks actually follow each other. So they're following the same cycle, and both of the tanks are now performing optimally, which was the purpose. So hopefully that answers the question. I think what we'll do now, because I'm conscious of conscious of everybody's time, and we're on to 10:28. So just to summarize what we've seen here, it's a new way of measuring nitrate in aquaculture. We will provide a summary of all these questions and answers. We'll just provide a little PDF document with the questions to circulate amongst all the attendees. Once again, thank you very much for your attendance and the interaction with the questions. We will be having another aquaculture-based webinar probably in the next month or two, focusing on different applications. So please join us again. And obviously, as I mentioned, we're going to be having a webinar around the greenhouse gas reduction and energy reduction applications in aeration basins. So if you could you watch out for that one, Shayna. We'd love to see you on that one as well. So without further ado, thank you very much for attending, and we'll see you all again soon. One last question: operation range and accuracy. Just cover that one just before we sign off, Eoin, just very quickly for Lee Zhao.
Yeah, so the range, very, very broad range, low ppb levels all the way up to 500 milligrams per liter as NO3 for nitrate, and 0.05 all the way up to 100 milligrams per liter as NO2 for nitrite. And accuracy, as I was saying, 95% is what we expect from the analyzer. Really, the range is we configure based on the application, but really the analytical ranges for both NO2 and NO3, they're applicable to essentially all environmental and industrial water applications. So, and there is leeway on that as well. We can tailor that slightly as well. So, I mean, if you have an application in mind, please get in contact. I think we'd be confident that we'd be able to deliver what you need.
Okay, and this time we really will wrap up. So thanks to everybody for hanging around. I see we still got nearly everybody still here. So thank you very much for giving us your time and attention. If you've made a note of that email address and you have a specific requirement you'd like to discuss in detail, as Eoin said, please get in touch. And thank you very much for joining us. See you next time. Thank you.
Thanks,
Bye-bye.
everyone. Bye-bye.